Hey, welcome everybody. We are going to continue our discussion of lines. Okay, so this is more stuff that many of you have had exposure to in high school. So in the middle of the screen here, you're going to see a very important formula. This is called the point-slope formula for a line. The name point-slope is very good, very descriptive. It tells you exactly what you need to be able to use this formula. You're going to need one point and the slope of the line. Okay. And you're going to use this formula if the directions ever say something like write the equation of the line. And it might say more, right? Write the equation of the line that passes through this point and is parallel to this line or something like that. But as long as you see write the equation of the line, blah, 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 you know that you'll be using this. We actually use this quite a bit in calculus. This is kind of our go-to for writing tangent lines. So it's not going anywhere, you guys. It'll be around for a long time, okay? All right, so use the point slope formula to write an equation of the line. There you go. The keywords write the equation of the line, right? Having the given conditions. Actually, it straight up told you in this problem. Usually it won't. Write the answer in slope-intercept form if possible. Okay, so while we're going to start with point slope, so while we're going to start with y minus y1 equals m parentheses x minus x1, right? The ending is going to be in y equals mx plus b. Okay, so let's go ahead and use this. All right, so this is going to be my x1 and my y1, and the slope is, of course, our m. We're going to substitute these into this equation. Y will just stay y. You're not ever going to substitute anything into that, okay? So we're going to put the 2 for y1. We said the slope was 2. And we're going to put -4 for the x1, which gives us 2 negatives, right? We already know if we have 2 negatives in a row like this, that's going to become a plus, right? So we have y minus 2 equals 2 parentheses x plus 4. Now we have to get this in slope-intercept form. So let's go ahead and distribute. And then we'll add the 2 over. Because as you recall, slope-intercept form, which is y equals mx plus b, it has the y by itself, like we just did. We isolated the y. So now, since this is in y equals mx plus b, we are done. We've got our y, we've got our m, which is 2, and our b, which is 10. Okay. All right. And just to give you an idea, if we were to graph this, right, the y-intercept would be the last number, so 10 or 0, 10. You would have to go up here to 10 and put a dot. Then we know that the slope is 2, but we'll put 2 over 1. And remember, we have to decide, are we going up or down? Are we going left or right? Well, since it's positive, we're going up. Since the 1 is positive, we're going right. So we would go up to right 1, which, as you can see, we go up to 1, 2, and then right 1. That's going to put us right here. We could have also have gone down to left 1 and had a dot also, okay? And I'm just going to keep doing it, down to left 1, down to left 1, to get just a really nice line. All right, so I'm going to go ahead and draw the line through it, you guys. There's our line. Now, what I want you to notice about our line is it does have a slope of 2, like the directions say. And let's check and see if it passes through the point -4, 2. It better, right? So let's see. -1, -2, -3, -4, and then +1, 2. Yes. Okay. So it does pass through -4, 2 right here. So it did exactly what we wanted it to do. Okay, let's try another. All right, so same direction. So let's write down our point slope formula. We will label all of our pieces, x1, y1, and m. We'll plug them in. Y minus y1 equals m parentheses x minus x1. Okay. Y take away 0, well, that's just y. 7 take away 0, well, it's still 7, right? So y take away 0 is y. We're going to go ahead and distribute the negative 2/3 into the parentheses. A negative times a negative equals a positive. So we have to do 2/3 times 5/1. So if we multiply straight across, it looks like it's going to be 10/3. All right, and it's already in slope-intercept form. Our answer here is already in good old y equals mx plus b. So we can clearly see that the y-intercept is the last number. So 0, 10/3, which, by the way, because we have to graph this, we might as well turn 10/3 into a fraction. So 3 goes into 10 3 times with 1 left over. So this is going to be 3 1/3, or 3.333333, whatever. Okay. And then the slope, we already know, they gave it to us in the directions, right? Now pick where you want to put that negative. In the directions, the negative is kind of ambiguously off to the side, right? So you have to pick whether you want to put it with the top or the bottom. I put it with the top. That's what I usually do, but you're welcome to put it with the bottom. Okay, so since it's negative, the top, the negative 2, will be going down, and then 3 is positive, so we'll be going right. All right, so let's go ahead and start at 0, 3 1/3. So 1, 2, 3 1/3. So like right there, that's about 3.3333. All right, and from there, we're going to go down to right 3, down to right 3. So down 1, 2. So I'm about right here. Let me try to make that clearer, you guys. I'll use a different color. So going down 1 would be going to the exact same spot. So about right here, that'd be going down 1. And then I'm going to go down another one in the exact same spot. So there's my 2. Okay, so 1 is there, 2 is there. So down 2, and then right 3. So 1, pencil slipped, 1, 2, 3. So about right here. Okay. And then we'll just draw the line through it. There we go. Okay. So it's supposed to pass through 5, 0. Let's see if it does. 1, 2, 3, 4, 5. Wow, I mean, of course, I didn't draw the line perfectly. It is a tiny bit high if you look at it, but close enough for us, right, to be able to think that maybe it could go through 5, 0. All right, awesome. Okay. Now, in order to use point slope, remember we need a point and the slope. That's why we named it such, right? So in order to use point slope formula, okay. In this problem, we're only given 2 points. So we need to find the slope. Okay. So earlier in the class, specifically last section, we learned the formula for slope. So we learned that m equals y2 minus y1, 2 minus x1. So we're going to go ahead and label the points up here. We can substitute them into this formula. So here we go. Okay, so we know that all those double negatives that we have, right? All these minus will turn into pluses. So it's really 1 plus 4 and negative 2 plus 1. But don't leave it like this. you want to actually divide this out. So a positive divided by a negative is a negative, and 5 divided by 1 is 5. Okay, so now that we have our slope, right? Now that we have that, let's go up here and now we'll use the point slope formula. So we'll go ahead and substitute in everything that we know. So y minus y1, which if you look up here at the top is -4, equals m, which we just found down here at the bottom of the screen, right? And x minus. So the minuses will become pluses. So this is y plus 4, x plus 1. So all of these minus a negative, those will become pluses. All right, we're going to distribute -5 into these. And then subtract the 4 over. Now, on a side note, I'll talk about this more. I'll do it on the next screen. We said to use point slope, you just need a point in the slope. You didn't necessarily have to use the point -1, -4. You could have used -2, 1, which actually would have been maybe easier. You wouldn't have to deal with as many minuses, right? And we'll do that in a second, but let's just go ahead and graph this really quickly and make sure that this is indeed what we were looking for. All right, so we know that our y-intercept, which is what we always start with, is the last number, so 0, -9. And this graph totally does not go to -9. So it's making me question myself here. Let me double check. No, we did good. Okay. So I'm just going to make some more spaces. 6, 7, 8, 9. So we're down here at -9. All right. And then the slope we know is -5, but let's just put it over 1. So we have to ask ourselves, are we going up or down? Are we going left or right? Well, since it's negative, down, and since the 1 is positive, right. So we're going to go down 5, right 1. But look at our graph, you guys. Going down 5 and right 1 would put me off of my graph completely. So instead of going down and right, I'm actually going to go up 1, 2. Boy, that's off a little bit, huh? I'm going to go up 1, 2, 3, 4, 5 to get to here. And then I'm going to go left 1. Remember we said it's the same if you do the exact opposite. So instead of going down and right, we're going to go up and left. And let's do it again. Up 1, 2, 3, 4, 5, left 1. Up 1, 2, 3, 4, 5, left 1. Okay. Now it's going to be slightly off, you guys, because I drew the graph there, you know, the -9 that we started with, but let me go ahead and move this guy to where, okay, close enough. All right, so did he go through -1, -4? Well, let's check. -1, -4. Here's -1, so we go to the left 1, then down 1, 2, 3, 4. Perfect. Here is -1, -4. And did he go through -2, 1? Well, from the origin, -2, up 1? Yes. Good about our equation now. Okay, so what I was talking about a second ago, where it doesn't matter which point you use. Let me go ahead and just copy really quickly. Let's do a little screenshot here of this. Let's add in another slide here. So comments are, when using point slope, you can actually use either point. What that means is use the easiest one, right? Okay, when using the point slope formula, you can use either point. So pick the one that seems best to use. I hate how it puts it right on top of it. Oops. Oh, it's the easiest. Okay. All right. So if we go back to that moment in time where we were doing the point slope, we didn't have to use this one, in other words. What we could have done is we could have used the other one. So y minus, and we could have used this y value, y2. And then we could have used this x value, -2. So x minus -2. And while it seems completely different, like there's no way that this equation is going to amount to being the same as this one over here, but it turns out it does. Let's just follow the math through and hopefully we get the same thing. Okay, so minus, that'll become plus. We're going to go ahead and distribute this -5 in. Over. Same exact equation, you guys. Okay. So, I mean, if something obvious like one has fractions and or decimals and the other one's integer values, of course you would use the integer values, right? Maybe you might like this one better. If it has all positives, that's probably easier to use because you don't have to deal with this minus stuff, right? So stuff like that. So pick the easiest is the moral of the story. Okay. All right, we want the line that passes through 2/3 and the slope is undefined, or 2/3. So this is my x1 and my y1, but we are missing the m, right? Okay. So let's think about this. It says the slope is undefined. If you recall from our earlier, okay, the slope is undefined. It must be a, do you guys remember which kind of lines have an undefined slope? It's got to be like either vertical or horizontal, right? So undefined is straight up and down, right? It must be a vertical. Okay. And remember, all vertical lines are x equals. So the equation must be of the form x equals a constant. Okay. In cases like this, when you have a vertical or a horizontal line, you might not even really need to use the point slope formula. So in cases where you have a vertical or horizontal line, you sometimes can't use the point slope formula. Okay. So what I mean by that is, if my slope is undefined, it's not like I can go in here and just be like, yeah, y minus 3 equals, and then write the word undefined for the m, and then x minus 2. No, it doesn't make any sense. Like, what the heck is that? So we're just going to have to kind of use our brains and a picture. So we have the point 2, 3. So 1, 2, and y-axis 3. So we're right here. And we know because the slope is undefined that this has to be a vertical line. So that is our line. So if we were going to write the equation of that line, it's going to be x equals, and it passes through the x-axis at 2, right? So it's just going to be x equals 2. These are my favorite. I don't have a ton of work to do, and I just go, okay, which axis did it cross? It crossed the x. Okay, x equals, what number did it cross at? It crossed at 2. So I love these. All right, so now we're going to talk about parallel and perpendicular lines. Okay, parallel lines have the same slope. That's what keeps them parallel, right? If I have a line like this, and then I have another line that's not parallel, it's off a little bit, well, then eventually it will, cross eventually, right? Okay, if these keep going, they'll touch. So we know that parallel lines must have the same slope in order to stay parallel and never intersect, okay? So parallel lines have the same slope. Okay, perpendicular lines. I find that a lot of students don't know what the word perpendicular means, okay? So let's make sure everybody here understands what perpendicular means. Perpendicular means that if you have one line, the other line is going to create a 90-degree angle with it, a right angle. Okay, I'm kind of sideways, so hopefully this looks close to a right angle. Okay, so there will be a nice 90-degree angle right there. That's what perpendicular lines mean. Okay, they're going to make a perfect T, in other words. Okay, so perpendicular lines, so let me label this. These will be our parallel. Perpendicular. Okay, they don't have the same slope, obviously. I mean, look at them. This one over here, this one has to have a positive slope because it slants towards the right. This line over here has to have a negative slope because it slants towards the left. So no way do they have the same slopes, okay? So it turns out that their slopes are going to be opposite reciprocals. That's our mathy way, reciprocals. Or just a non-mathy way, flip it and change the sign. Okay, flip it and change the sign. And they say it extremely mathy up here, but this is basically their way of saying flip it and change the sign. Okay. All right, so let's go in here, go through some of these. The slope of a line is given. Determine the slope of a line parallel and perpendicular to the given line if possible. All right, so we already know parallel lines have the same slope. So if the original line slope was -3/8, our parallel line will have a slope of -3/8. Now for the perpendicular, we have to flip it. So instead of 3/8, it's 8/3. And then we have to change the sign. Instead of negative, 3/8, it's going to be positive 8/3. Nice and easy. Give me a bunch of these, right? All right, parallel's the same. So 20 and 20. Perpendicular, you got to flip it. So remember, underneath every number, there is a 1. So when I flip this, it's going to become 1/20, but I also have to change the sign, so it'll be negative. All right, parallel should be exactly the same. Now we can't really go flipping this because look what happens when we flip this. If we flip this, it would be 1/0. But we know that any time that we have 0 in the bottom, since we cannot divide by 0, that the answer is undefined. Okay, so the slope of this is undefined. Remember what that means? That means it must be a vertical line. So let's just take a little look at that and make a comment here. Yeah, undefined. That means well, let me talk a little bit more. So the original line has a slope of 0. Okay, since the original line has a slope of 0, it is horizontal. We did our video on slope. Remember we said, well, what would you give? What slope would you give to a horizontal line? You're like 0, it's not really sloping, right? Okay. Now, if I have a vertical line, a horizontal line, and I want to have a line that's perpendicular to that one, well, in order to make a 90, I'd have to go straight up and down, right? So this is our original, which has slope 0. And then this one is going to be the perpendicular line. And this one would have a slope of undefined. Okay, since the original line has a slope of 0, it is horizontal. So the perpendicular line so hopefully that made sense to you guys. All right. Give the equation of a line. Those words tell us right away, or write the equation of the line. Give the equation of a line that I should write down point slope. And so we already have our x1 and our y1. So the only thing that we're missing for point slope is the slope. Let's think about this. So how can we get the slope? Well, this line that we're writing the equation of is going to be parallel to that line given in the directions. Y minus 3x equals 4, okay? So the line we need the slope of is parallel given line. So that means it will have the same slope. So let's find the slope of the given line. So how would we find the slope? Well, if it were in y equals mx plus b, then the m would be the slope, right? So we need to get this into y equals mx plus b. So we'll just take this 3x over to the other side. We got it, guys. So it'll be a positive 3x. So you can see from the y equals mx plus b, right? That the m is going to be 3. So for our line, or how about this? Let's write the slope is 3. The slope is 3. Okay, so since our line is supposed to have the same slope, m equals 3 is going to be the slope for our line. So we're going to take that and we're going to substitute that in. All right, so let's substitute everything in. Y1 we know is 2, looking up here at the top again. We just found the slope is 3, and then x minus x1, which is at the top. Okay, so we know that the minus minus will become a plus. Go ahead and distribute. Okay, and we'll add 2 to both sides to get it into step form, aka y equals mx plus b. That is the equation of our line. I do want to get a picture. So if you're looking for pictures, you can use GeoGebra, or you can use Desmos, or there's lots of different graphing calculators out there. Those are probably the two most famous ones. So for our, we know that we pass through -1, 2. So I'm going to put -1, 2 on here. And then we also, they gave us y minus 3/4 x, y minus 3x equals 4 as the line that we want to be parallel to. So I think we can all kind of visualize that this line needs to be something, you know, like, so I can write on it. This line has to be something like this, right? It's got to be parallel to the given line and passing through that point, okay? So I'm going to type in what we got, which I totally don't remember. 3x plus 5. Okay, so let's go ahead and type in y equals 3x plus 5. And look at that. That's perfect, right? That line is exactly parallel to the given, but it passes through the point that we wanted. Okay, so this is really, really good. Let me go ahead and label these lines to y4 that they gave us in the directions. This one is okay. This is really good, you guys. Give the equation of the line. Okay, so again, write the equation of the line so we know we're using point slope. We know our x1 and our y1. The only difference this time is they changed the word on us, okay? So this is very similar to the last problem. in that we need the slope still. But this time, instead of parallel, it's perpendicular. Okay. So we need to get the given line or equation into slope intercept form. Find its slope. Then, since it's parallel, right? Since our line is parallel to the given line, we will need to flip it and change the sign, right? Opposite reciprocals, guys. All right. So let's go ahead and take the line that they gave us. I know this is a line because both x and y are to the first power. So we know we're staring at a line here. All right, so let's start to get this into y equals mx plus b form. It will be negative 5x when it passes across the equal sign. We'll just divide by 2. Yeah, I don't know why I'm boxing that. All right, so the slope is negative 5 halves, okay? So the slope that we want, we have to, since we have the word perpendicular this time, flip it and change the sign. So it was a negative, so now it's going to be, this one's negative, right? So this one's got to be a positive, okay? All right, so we're ready to substitute this in to our equation. So here we go. Y minus y1 equals m parentheses x minus x1. So we'll go ahead and distribute 2/5 in. Okay, so if I'm multiplying by 5. So now we're going to add 8. Again, for those of you, the recommended calculator for the class from the syllabus is the Casio 300 FX, right? It'll do all this fraction stuff for you. So if you're stressing because you don't remember fractions, then just type into your calculator negative 12 over 5 plus 8. Now remember, there's a difference on the calculator between the negative sign and the minus sign, right? So if we're looking at, let's say we take the Casio 300 FX, whatever. Okay. This one. So, and all calculators have this. Oh, that's huge. Okay, so let me see if I can, that's really zoomed in, huh? Okay, so I'm going to screenshot this. Whenever I pass over it, it gets really big. Okay, so let me take a screenshot. On the Casio, which is the one I recommend for the class, trust me, guys, it works for chemistry, physics, all the way through calculus 2, probably beyond, but I only teach up to calculus 2. All right, this is your minus sign, guys. This is the minus. And then this is where your negative is. So if you want to type in what we're trying to find out right now, negative 12/5. Okay, make sure that you're using the negative right here. Okay. Otherwise, it will tell you error. Okay. All right, negative 12/5 plus 8. I don't have, I never have a calculator with me, guys. So negative 12/5 plus 1. I'm just going to go ahead and do it by hand. So times by 5 times 5. We're getting common denominators. So it's going to be 12/5. I think that's 28/5. You guys will have your calculators. Hopefully. All right, so that's going to be the equation for our line. In fact, you know what? We'll find out right now. Let's go ahead and get a picture of this, okay? So we want to pass through 6/8. Let me go back to GeoGebra. And I think it was what, 2y minus, I can't remember you guys. 2y plus 5x equals 10. 2y plus 5x equals 10. Okay. 6/8 is kind of off our screen. There it is. Okay. So we want to be perpendicular this time, huh? Perpendicular. So that means we want our line to be something like this, where it's going to make like a 90 in there, right? So let's go ahead and type in what we got for our 2/5 x plus 28/5. Yeah, that looks awesome. Okay, it goes through the point. Got to do two things, right? It has to go through the point, which it does right here. And then it also has to make a nice 90 with larger. And let me go to the next slide and put it in really quickly. Okay, so it does go through the point. And for that given line, it did make a nice 90. Oh, I'm sorry, that's not the given line. Huh? Given line. What's this one in blue, right? This is the one that we got. Perfect, you guys. That was spectacular. Okay. All right, so let's take a look at some possible word problems here. The local hardware store charges $28 to rent a carpet cleaning machine for 24 hours and $10.98 for each medium-sized bottle of rug shampoo. Write a linear function S that represents the cost of renting the machine for X days along with 2 bottles of rug shampoo. Okay, so they tell us our function has to be called S. So you can either write S or S of X, you might see. I'm not sure what Connect Math is going to do. Both are acceptable to me to put an S or an S of X, okay? All right, let's see here. We are renting this machine for X days. How much does it cost a day here? The local hardware store charges $28 to rent it for 20. So it's $28 per day, right? $28 per day. So that means it's going to be $28 times X, since we have X days. Okay. But then we have to add to that the fact that we got 2 bottles of rug shampoo, right? Okay. That's going to be 2 times $10.98. Okay. So 10, if we do 2 times 10.98, $21.96. Okay. So that's how much we would have spent on shampoo. So let's add that to the bill. All right, so there's our equation for how much it's going to cost to rent this machine and get some shampoo. So it says evaluate S of 2. So in other words, we're going to substitute 2 in everywhere where we see an X, right? Okay, so 2 times 28, I believe, is 56. And then we just have to add $21.96 to that. Okay, so 77.96. And now it says interpret the meaning in the context of this problem. So what does S of 2 mean? Well, remember, we put the 2 in where the X was, right? And X stands for days. Okay. So we must have rented the machine for 2 days, okay? So the cost for renting the machine for 2 days and buying bottles of rug shampoo is $77.96. So the main takeaway from this screen is really this last one. I want to highlight it and I'll talk a little bit about it. Okay. So there's words here. I think everybody has heard costs. Like if you own a company, let's say you own a Del Taco, you franchise the Del Taco out. Well, you have costs, right? You got to rent the space. You've got to hire employees. You got to buy lettuce, all that stuff's your cost. But a word that might not be familiar to a lot of people is revenue. And really what profit, the difference between these revenue and profit, okay? So you own your Del Taco, at the end of the night, you count the money in all the cash registers and you count the money in the safe, right, that you earned for that day. That would be your revenue. That would not be your profit because you don't get to keep all of that money. From that money, you will take away the cost, right? So you'll use that money to pay the employees, pay them the rent, buy the lettuce, okay? So revenue is not what we get to keep. It is not our profit. Profit is genuinely what we get to take home, how much money we made for that day, year, whatever it is, okay? So you can see over here, what this is saying is that to find the profit, you're going to take the money you made, you're going to subtract away the costs, and that will get you your profit. Okay, so you're going to take the profit, it's going to be the or to find the profit, it's going to be the revenue minus the cost. So let's look at this. Alina is starting a summer business power washing home driveways and sidewalks. She will charge $35 to pressure clean a driveway and the sidewalk in front of a house. Her startup costs include her initial purchase of a power washer for $3.30 and a fee of $2 per house she must pay to the homeowners association for the use of the water for each house. Okay. All right, so we're writing a linear cost function, we're writing a revenue function, and we're writing a profit function. So let's go in and think about what kind of costs she has. So for the cost function, C of X, her costs include the initial purchase of a power washer for $330. So you just have to think if that gets a variable or not. Well, it's just a one-time fee. It's not like $330 per blah, blah, blah. It's just she bought the power washer, done. So it's just a flat $330. This fee of $2 though, it's not just going to be a flat 2. It is going to have a variable after it because it's $2 per house, right? Per house implies that it needs this X after it, okay? So that's going to be her costs. Let's go ahead and write the revenue function. So how does she make money, right? So for the revenue function, let's see, she's going to charge $35 per house, right? Okay, so she's going to make money, $35 per house. So it also gets a variable. It's not a flat 35 bucks she made, it's $35 per house. And that's the only money I see coming in for her. That's the only revenue for her. Now, in order to get her profit, P of X, you had to take the money she made and subtract away all of her costs to see what her profit is. So we're going to take the 35X, we're going to subtract away the cost of 330. Many students forget the parentheses, you guys. You have to have the parentheses because if you don't, you'll forget to distribute, right? If you just write it without the parentheses, get the wrong answer because these two you would add together. That doesn't make sense. She's not going to make $37 per house, right? She charges $35 per house, but then she has to pay $2 for the water. So really she's only making $33 per house, right? And that's what distributing this negative is going to show. It's going to show that she had 35, right, per house. But now it's a negative 2x because we distributed the negative. So So when we combine like terms, 35 take away 2, she's really only going to get $33 per house then. So this is going to be the equation for profit function. I'm going to go ahead and copy that. Next slide. How much profit will Alina make? Okay, so yeah, so let's go ahead and put that guy in right here. If she wants to wash 15 homes. Well, remember the 15 is X, you guys. The homes is the X. Oops, sorry. A little red there. So we're going to substitute 15 into this equation wherever we see the X, right? Oops. Okay, so if we do 15 times 33, okay, so she will make 165. How many homes must Alina power wash to make $330? So I don't want to put the $330 in for the X. X stands for the number of homes. Plus, when we say how many homes must she wash to make, we want this to be her profit, right? So it must be going in for the profit. So we're going to substitute it into the left-hand side. Wait, 22? Okay, so that's going to be 66. Yeah, okay, so she would have to wash, 20 homes. I don't know why I thought that number was too big, you guys. Okay. All right. So 20 homes in order to make $330. Okay. Let's see if we have more. No. Okay. So hopefully you feel comfortable, you guys, with using the point-slope formula and the difference between the slopes of parallel lines and perpendicular lines. Those are the big takeaways from this section. Okay. Good luck on your homework, guys. Take care.